All right, hello and welcome to the Node Operators call. Today is March 13th, 2024. We have a couple of topics to discuss today. Top of the agenda is finalizer key management for the upcoming release and transition to Savannah Consensus with Leap 6.0. For those who aren't familiar, Savannah is kind of the code name, if you will, that or the branded name is maybe another way to put it, for what we had previously called instant finality. And so high level, this is going to take us from the current consensus with finality times of several minutes down to a much faster finality time of just a few seconds. This has been the primary focus of developers within the ENF and of course also the contributions of Guillaume's team as well. So lots of time and effort going into this, and we've been in kind of a prototyping stage for a while, and we're now at a point where soon we will have some release candidates and early access releases and things like that coming everyone's way. So timeline wise, it's early summer is when we're hoping that this will be activated, and prior to that there will be a test network phase. The topic of finalizer key management relates to kind of the internals of how the new consensus works, which introduces a new role, which at least in this initial release is still tied to block production, or in the terminology of Savannah, block proposal. But and that new role is called the finalizer role. So even though it is tied to the same sort of currently logically tied to that block proposing role, it requires separate keys due to the sort of cryptographic nature of those keys and what they enable. So it uses a different curve basically that has the property of being able to aggregate signatures, which we're able to exploit to efficiently reach consensus on finalization. So that's the 10,000-foot view. Kevin could geek out much more than I can on that to give you a lot of details on how it works. But the purpose of what we want to discuss today is just getting setting some context and getting some feedback on what block producers' requirements might be for actually managing those keys, because you're going to have two sets of keys for any given block producer node, and one of them is a new and different type of key. And so all of the security considerations and whatnot that go with storing keys, redundancy and all that, is something that we want to go over in some detail and make sure that we're accounting for all of the needs that you might have. Before we sort of go to open floor, Eric, is there anything you want to add to set context on this conversation?
No, the link that Kevin provided, I think, has what I would go over. So I would just be reading that. I mean, that's got the key details in it, which I can do. I can read.
Yeah, maybe perhaps not word for word reading, but at least a quick tour of the link, just to make sure everybody's on the same page.
All right, so block producers are going to have to register these new keys. You're going to have to run a Leap utility command, and you're going to get a public key, a private key, and a proof of possession. And you're going to have to store these things. So I mean, I think that's a good conversation in and of itself. But once you create them, you're going to have to register them as well, system. And there's going to be some mechanism that's going to keep this to only block producers being able to register keys. We haven't gone through all those details yet, but that is the intention. And when you register a key, the first key you register is going to immediately become the active key by default. And then you can go on and register multiple keys after that. We have this desire to be able to add new keys or delete keys, which would, I guess, act as a key rotation. But since we haven't actually implemented the code yet, I'm a little hesitant to go into how exactly that is going to work or how it wouldn't work. But we do have Instant Finale running today, and what we do is we register these keys, and then we run an action with the right once the right protocol features are in place. We run an action, and it flips over to the new consensus model. So it is, it is working today. We do use these keys today. These keys are in there. We know what format they're going to be in. They're in their final format. I guess I'd stop there because I think the rest of there should be some questions about how everybody does things differently, but the life cycle that they use for bringing up a new node, or if, I don't know if you have to ever switch physical machines, right? How you do that. And I'm curious about any questions you may have about the sort of day-to-day, week-to-week, or month-to-month operational things that come up, that these keys might be an additional management task. I'm curious to hear what people think.
One additional thing there is in 6.0, we are not planning to support KOSD. I'm not sure if any block producers currently use that for signing blocks. If any do, please speak up. So we're just planning on supporting either command line or config.ini of signature provider. So it's the same signature provider, only you'll be able to also specify a base 64 URL encoded finalizer key.
So basically, we get a new key. We have another plugin that functions similarly with config.ini that you put in and run. The finalizers are ultimately the same node, 99% plus this little, just like a VP.
They don't have to be. There's no requirement that the block producer node and the finalizer node needs to be the same node. There's no requirement for that.
Right, not same node, but I mean, ultimately they function similarly. They're 99% the same like all the rest, assuming you use the same settings.
So
it's just this plugin, this signature provider, and knowing that it needs to do finalization, correct?
Right. So pre-Savannah, what we're calling it now, is, a node has 3 rows as a block producer. So, and I think we'll save the term producer to kind of represent all 3 rows. So a block producer, at least in 6.0, a block producer proposes a block, produces a block, and finalizes a block. So it does all 3 of those rows currently. And we've just referred to that always as just a block producer. So in 6.0, those rows are separated conceptually. And then also physically, they can be separated in 6.0. So in 6.0, there'll be a block proposer, which is what similarly would be a block producer in the past. So the ones that get to propose a block are the ones that have the most votes. So DPoS chosen block proposer according to vote ranking. So that's the same. Those will be the block proposers.
Correct, and those are the ones that are basically executing the transactions based off of the CPU
Yes,
that we can throw at it and
yes,
then say
exactly.
here.
Exactly. And so, and then they'll propose a block, they'll actually produce that block, which is what you're talking about. And then there's another step of finalizing a block. So those used to all be kind of done together. The finalizer part of that has been broken off now in 6.0 in Savannah after that's been activated and enabled. So that row can be on a separate node. Now, what we're enforcing in 6.0 is that the same entities that get the votes to be able to propose a block are the same entities that are going to finalize the block. Now, those can be separated in the future. You know, we talk about like there's a different mechanism for choosing finalizers than there are for proposers. But in 6.0, you know, we're keeping that all simple and together, where those are the same entities in the sense that we're going to require all block producers to have a finalizer key registered, or they won't be allowed to be a block producer. So because we want to make sure that we have at least 21 finalizers that are active. And so that's what we're going for in 6.0. That can change in the future. But you as a node operator can run a node. You will register both keys. You'll have your block proposer key, which would be your normal key that you currently have, and then your finalizer key, which will be a BLS key, BLS base 64 URL encoded a BLS key, which is your finalizer key, and there's a Leap util that can generate that for you. So you'll have that key, you'll register that key. You can run that finalizer node separately as a separate Nodius running instance, or you can run that on the actual BP as well. Either way. I think there's probably reasons why you might want to run that separately, but you can run that node, then it will finalize those blocks. And so to be once that's enabled, to be a block producer, we will choose in the reference contract that I linked here. It will choose block producers according to the top 21 votes who have both a proposer key that's registered, which is true today, and they'll be required to have a finalizer key registered. If they don't have a finalizer key registered, then they will be skipped over in terms of the top 21 producers that are chosen.
Makes sense. I mean, that I can speak on it and maybe some from what conceptually I'd do as a node operator. I'll leave it open if anybody else has any more questions, maybe at that stage.
A few before you go into that, Michael, a few basic clarifications, and also want to look at some of the comments in chat real quick. So first of all, just to make sure it's super clear, these finalizer keys are only required for people who will actually perform the role of finalizing, which for 6.0 are just block producers. So if, you know, for any applications or users or anything like that, you know, finalizer keys won't be required, just block producers. And then so there was the question about storing the keys, and as Kevin pointed out,
Command line wallet.
yeah, the KSD won't really be updated, so it won't support these. Having said that, the question is, will we need to migrate our existing wallets? You will need to use some other storage mechanism for these new keys, but your existing keys can be stored as they are now. So only if you want some sort of unified key management would you need to do some form of migration. But you'll be able to use your existing key management for your, to be clear, for your block producer keys. But you'll need some other way to store these new finalizer keys.
Oh, I was going to say, as I understand, I mean, it's kind of like that misconception about your signing keys, signature provider, I guess, as you might say, needing to be in your wallet, which they really never do. You don't really use them. You only register them that they're there and in the config. So I assume these new, call them BLS keys, base 64, whatever magic voodoo Kevin keeps calling them. But is that what one looks like? Yeah, so anyway, while they may be keys, they're not particularly stored in wallets. They're more just like configs in your INI and managed and handled separately. Maybe that's part of that conversation you were starting down, key management. But is that correct that would you equate these new validator keys or whatever, just like the signature provider keys, which could be imported into EOS D before, but really didn't need to be for the sake of block production? You use your active key for the account, which is what the block producer account is, or owner key, I guess. Right? I mean, did that kind of make sense to the nerds? I mean, it's really just a key in a config file. It's not so much a key in a wallet that you need to call to authorize anything, right?
Yeah, that's exactly right.
Okay.
Appreciate you going through that. I posted in the chat like an example from a test run. So like, you know, I know most people put this in config.ini. Our test, we actually do it on the command line. Either one works. But, you know, so here I posted, here's an example. And you see that like there's both a, it's the same command, same argument, signature provider. And you'll see the first one there is the EOS, you know, that's the proposer key. And you'll see the public key and private key there. So yeah, I just leaked this private key, but this is just throwaway key. And then there's a same thing, exact same argument, signature provider. And you provide the BLS a public key and the BLS private key, which are both there listed. And so yeah, you do that in, I think most block producers do that in their config.ini. It is possible today to do that via the KeyOSD. My understanding is nobody uses that feature. If there are block producers that do, please let us know so we can prioritize that work for maybe a future release. At this point, we don't think that's going to make 6.0. It's not in our roadmap for making 6.0.
So you're saying you could actually have a run KeyOSD providing those keys as a signature provider?
You can, yes, today, yes.
Didn't know that.
Yeah, so it's a feature. I don't know how many people actually know it's a feature. I don't think any block producers actually use that feature. Maybe they do, but it is a feature.
Huh, interesting. So
it's been around since the beginning almost. Like
yes.
it's always
Sounds
in the
like it.
manual, the EOS-help or no EOS-help.
No, my
Yeah, I don't think anybody uses it.
config.ini example that I got did not include that option, so therefore it never existed for me. So
Yep.
anyway, duly noted.
So let's walk
anyway.
through real quick. Let's walk through kind of the anticipated flow a bit here. So like obviously before you can register or store keys, you first have to have them. So there's a key generation element. So Kevin, can you walk through how you would anticipate that block producers will, well, finalizers, I should say, will generate their keys for the finalizer keys in the first place?
Sure, absolutely. And I just posted it in the chat there. It's a new option to Leap Util. So not CLIOS, but Leap Util. So Leap Util, you do a BLS create key, and it has similar options of the CLIOS's create key. You can do it to the console, which of course we don't recommend because consoles are logged typically, and so you don't want that there. But there is the option to save it to a file, which I'd recommend you do, is that way it's not echoed onto your console. And then it's in your file, and you can have access to that. And then you manage that private key, just like you would your current proposer private key. However you manage that today, you would manage that the same. And then you put that in your config.ini typically, or command line, whichever way you typically do that for your proposer key. Do the same thing for this new key. So you'll just be managing two keys now instead of one. You'll be managing your proposer key and your finalizer key. They're different formats, but ultimately they're just two strings for for the EOS, your proposer key, your public key and private key, and 2 strings for your finalizer key, your public version of that and your private version of that. And you manage those the same way, and you provide them to Node.js in the exact same way, -- a signature provider, or if it's in your config.ini, signature provider equals, and you can have multiple lines for that. So you can say signature provider and provide your public and private proposer key, and signature provider and your public and private finalizer key. Now there is this additional bit when you do that create, it will echo out a private key, a public key, and a proof of possession. Now the proof of possession you need to keep around as well, although you can regenerate it if you need to. So like if you lose your proof of possession, you can actually use the clearest util to regenerate that for you. But easiest way to just save it off with your private key. And that proof of possession has to be provided when you register your key. So you don't need to provide it to Node.js when you run it, like in the example I posted in the chat. I'm not providing the proof of possession to Node.js when I'm launching it. But when you register your key with the contract, with the system contract, you do need to provide your public key and your proof of possession.
Right. So we've generated a key. Presumably the next step is that we need to save our private key and proof of possession somewhere, right? Now this is a spot where some feedback on how node operators would like to do this would be helpful, just so that we can be on the same page. I don't know, Kevin, if you have.
I'm not going to discuss the detailed process of how I keep all of my super secure keys. We'll say I save them to the desktop of my, daughter's computer or something like that. Something stupid. But the point is, you have the key, and now this third string, which I'm curious. I mean, is it like a seed phrase or whatever type of recovery for the key?
It's not. No, it's not a recovery in any mechanism. So don't mistake it for that.
Correct. It's an extra key, maybe. It's
kind of
handle and a deadbolt. I mean,
it's a way to guard against a security attack on a DLS key. And so proof of possession, as its name maybe implies, it's a way of proving that you have the private key. So it's kind of like signing something with the private key.
So basically,
maybe I don't,
I'm
but
assuming
you don't use the private key. You actually use this third key that says you have the second key. That, I mean, I guess I could wrap my head around that down the road.
Yeah. So when you register your public key, you're providing with that this proof of possession, which indicates that you have the private key associated with that public key. To create a proof of possession, you have to have the private key associated with the public key.
I guess it addresses, maybe if I think about it the other way, what it fixes is the fact that when I register my block producer key,
right?
As a block producer, I have control of the account, but you don't, and people do it wrong a lot of times. I guess you're right. That the key that I'm registering doesn't guarantee that I actually have it. What guarantees it is when the alarms don't go off when I sign that block and and don't have the right key in my config or whatever. But yes, it's that extra layer of security of like a register producer.
It's not that, like I can watch the blockchain and see public keys come in, right? So I could watch the blockchain and also see a public key and a proof of possession. So proof of possession is maybe a little bit a misnomer in that it doesn't prove that you have possession, because I could see it on the blockchain and I could reuse it. And I could say, whoa, here's my public key and here's my proof of possession. And so I can mimic that, right? What it proves, and maybe a better name, but that in the BLS arena, that's what it's called, is proof of possession. And so we're using the term that the industry uses. What it proves is not so much that you have possession, it's that it exists. So you have to have a private key of this public key to create the proof of possession, which so it indicates that there is an associated private key that someone had at some point to be able to create this piece of data. And so at least at some point in time, somebody had a private key associated with this public key. It doesn't mean that I necessarily have that or you necessarily have it. It just at some point, somebody had it.
I mean,
Which is a little bit better than like no one had it.
I get that. I mean, is it semi-fair to call it kind of an extra private key just for the sake of the argument? Maybe the one-time private key at creation, whatever it is. But ultimately, you have these magic keys, and then you use, I'm assuming, Leap Util to register a key with register your finalizer.
So it's actually a smart contract action, which
Oh,
Eric
you can push it.
posted an
Okay.
example
Is it
here.
with you actually push it with Clios or whatever, or
Yeah,
blocks.io?
so today when you register to be a block producer, right? You
Yeah.
provide it your public key, you provide it like your
RegProd,
key and-
RegProd. What I know of is RegProd, which
Right.
is your key,
You
your
give it your
website, your
website.
location.
Yeah,
Okay.
you give it that bit of data. So now to be a block producer, you'll have to not only do a RegProd, you'll also have to do a whatever we call it in a new, whatever we're gonna call it in a new contract, register final key. I guess we don't even have we haven't specified what that action name is yet, I don't think. But yeah, you'll register a finalizer key. You'll have to do both things to be a block producer after.
Correct. Which is what goes into the contract with this public key and proof of magic that I have it, and tells the contracts for this new role, you should also look and expect these key pairs to do the finalization, which is ultimately simply added as a signature provider line, additionally, if it's the same node, into the block producer node, which is now block producer / finalizer. It looks at producer name, it looks at the two signature providers and uses them respectively for their roles. Does that fall into the producer plugin? I mean, there's no extra plugins to enable for that, right? I mean, it's all wrapped
no
into
extra plugins
wherever it is.
Right.
Perfect. Then I'd assume it's managed almost the same way we manage the current BP keys and key structure.
Right.
I think I heard him say, or somebody say, there's no key change mechanism. I assume you can re-register your key either to a new key or the same key, or deregister yourself. Going into the question about failovers and how we run, I also will assume or question what happens when two of them have the same key.
Yeah,
and try to double produce in hot stuff.
Yeah, we're not going to allow that. So one of the things that the contract will enforce is that you can't have duplicate keys.
But you can't register duplicate keys. You can't stop me from spinning up 50 nodes with the same key in my config file. Does that make sense?
Oh, I see what you're saying. Yeah.
Double producing. That's the other side of failovers. And I may be going too deep into the question.
You can do that. I'm trying to think what will happen if you do that. So if you do that, it's simply going to be whichever one happens to win the race. Like you can actually
double produce.
I have to talk about whether we want to encourage that or not. Like there's no harm in doing that. It's just it'll be the first one that gets there, and every one after that finalizes by the same key is just considered a duplicate. And we handle duplicates anyway because
I think
wouldn't it be a fort? Oh,
the risk,
no, I guess
yeah,
it's
the risk
validating.
is,
It's validating, it's not producing. I see,
right,
I
it's
see,
just
I
validating.
see.
So you can have multiple validators, and it'll be whichever one happens to validate it first. It doesn't really matter. Like those, from Notice's perspective, those are the same thing. And so it will take whichever one you get.
Correct. It's 2 thumbs up and it's just okay.
The second
Whatever.
one's just considered a duplicate and it's simply dropped.
So hang on, I'm bringing up a document that I've been working on with Arig and Eric. 1 second.
We don't want to encourage. We want to encourage unique finalizer keys on each
Yeah.
physical host.
I mean,
That's what I-
it doesn't sound like you want to encourage it because I mean, it's still got to deal with it and slough it off, and
It's just
my
open.
network would probably be wrecked because I'd locally sync all kinds of trash all over the place. But anyway, I do question because that falls into how we manage them on different nodes. If I can throw them on 50 nodes and be happy, of course, that's a totally different management versus you really need it to be semi-unique. Otherwise, you've got a lot of chatter and not forks of the chain, but micro forking into validation of which one is the right validator to accept. I don't know.
So one of the things that we're going to test in a impending testing
I'll test it.
that we're about to do is a finality violation where a single key is signing multiple. So it's this. The goal of this test is to identify a finality violation defined as the existence of 2 final blocks where each is not an ancestor of the other. And the reason I'm bringing this up right now is because part of the mechanism of that test is having multiple nodes share a key where those nodes end up in a fork situation, like have a different opinion on what what the final sort of blockchain is and should be. And that's what I think the reason or a reason to avoid having multiple nodes share finalizer keys is because you could find yourself in a scenario where you do have a fork, and if that happens, then you've committed a finality violation.
You get penalized for it?
Well, that's not in this first version, but I mean, it will be rejected, but that is a roadmap item, is that slashing may come into this. So, better to get into the hygiene now, right?
Awesome. Then yes, I would definitely consider the mechanics of it in the same way, at least personally, that we manage block producer keys. That's funny though. It's gonna have like a lot of other chains. Well done. It's gonna have slashing for double producing versus just fractionalizing the chain. Anyway, then that said, it's very difficult if you can't have multiple keys registered. I assume it's not an array. It's one key, one validator, correct?
We are going to support. You can read through that link. We are going to support multiple keys.
I tried. I wasn't quick enough, but okay. And and then it gets back more into maybe as long as they're both valid, you really don't care which one's there, and the account doesn't get slashed. It's not really causing the.
So if you look at what we have there, you're gonna be able to register multiple keys, and so that's one action, and then you'll be able to change your active key, and that's a separate action. And there are different actions so that you can set up different permissions, right? You could have a script that, for example, is just monitoring what's going on and change the key if you need to do a failover, where the action to actually register a bunch of keys, you can have a higher permission on and make sure that you only register your keys. You have a different.
And that's to change that. And that's to change the active, like the active key from the array that you already supplied, to avoid potentially wait for a new schedule or any of that. Like, it just knows you will accept that on the next block from that action.
That's right. And so that failover will be quick. We actually are still working on the design of the finalizer key host function algorithm for how quickly we can allow that change. But yeah, it'll happen quickly, so you can do it on chain, and then you'll be able to quickly fail over to a different finalizer.
So maybe I missed something on that, but if I register as a finalizer with 2 keys, and I run one node with one key and one node with the other key, and all the time, just wide open, and hope
Don't
well,
forget
one
the
goes
active
well.
key. You set one of them as active.
Right.
Well, that's I guess where I'm missing. I thought I didn't realize there's a denotation from that array of keys that denotes one is still the primary.
Yeah, one would be active. Yep.
Why? But I have to trigger another on-chain action to
Yep.
change to another key that's already in the array.
Right. To make it
What?
active.
What benefit is it having it on chain?
But everybody's aware of all the other keys already, and you're just updating which one to validate again.
Wouldn't that be the same as a re-register with the new key? Hey guys, here's something's wrong.
It
here's a new
is.
key.
It is.
It's not
The
gonna
idea of
fail
having,
over.
yeah, it is. It'd be exactly the same. The idea is that we're separating those two so that you could potentially have different permissions for who's allowed to do what, right? You might have, for example, you might want to have a script, but you don't want to give that script the permissions to, like,
Oh, it's
get rid of all your
purely
keys.
kind of at the permission level to say, here's an accepted set of keys already on chain.
Yep.
But mechanically, you still need to define which ones. Oh, so still no, it's not
Like a script
failover,
will
it's
be
a
able to
security.
change, for example, which is like the security, a script will be able to change which is active, but might
Right.
not
Correct.
have an ability to add or remove keys, right?
Exactly. You wouldn't want to just give a script that you have running on a machine, the ability to just, go haywire and take away all your keys and not be able to do anything, or if somebody gets a hold of that key, your operator or whoever gets a hold of that key that you just fired, and they want to, make you not a producer. Well, they can't, that permission to add keys is a different permission than the script that could be running your failover. You don't have to do it that way, right? I mean, you can obviously just, do that and only have one key and change the one that's there. And it all would happen the same
Right.
speed on chain. It's just, if you want to have the ability to separate out those two rows in the way you run your infrastructure, then you can. If you don't, well,
I got you, but it's not fail. It has no ability to really to fail over or be aware that if the active one isn't there, it's still going to be like, nah, the active one's not there. I'm ready, and I know that these other keys are probably going to be ones that they might use, and then can be triggered by a minion at low level or a script or whatever. But from a failover mechanism, it's still absolutely, you have to detect that you're not working, and then fire a script, fire an action.
Yep.
And then wait for it to take effect. Great news. It's 3 seconds, 6 seconds.
It'll take effect very quickly. We haven't actually worked out the algorithm for finalizing.
Purely because of the instant finality or faster finality of, hey, I mean, yeah, you missed a few, but you could see it quicker, you could react quicker, and it has this extra security layer, but it's still managed fundamentally, at least to me as a block producer, in that same mentality of, if you change it to a new key, that's the idea that there's another node that's been sitting there running separate infrastructure, whatever, that's ready to go as soon as the chain realizes it's okay.
Yep.
But it can't be the same key. It shouldn't be the same key.
Right.
That's constantly chattering, because just like double producing, you're going to cause not block production forks and rolling back transactions, but you're really going to start pissing off the finality micro forks, we'll call them.
Right. It's the reason that you have to register the keys and have them active is because we're counting votes. And let's say it's 1-for-1 and 1-for-1 block producer, active block producer and finalizer. That means there'd be 21, and we'd want 2/3 of that 21 to have finalizer votes, right? That came in, right? That's the scheme that we have. So if anybody can register keys and we don't know which keys are active, we don't know what votes make something final anymore. That's why we need the registration. We need to know how many potential voters are out there and the weight of those potential voters as well. That's why we need the registration.
Right. And one of the things that we're looking for feedback on, once we get this in testnet and you guys start playing with it, is like, how should we, or what mechanism should we have in place for monitoring the finalizers? Right now, you guys have all sorts of monitoring for if a block producer doesn't propose blocks during a round, right? You have alarms go off. There's Telegram channels. People get shamed into deregistering for a little bit until they get their machines up and running again, right? So you have monitoring for all of that. What we'll need is similar mechanisms. Now, ultimately, like we talked about, maybe slashing in the future and that kind of stuff. But 6.0, like we'll need monitoring to see that like finalizers aren't voting as they should, right? And so some feedback there on like what would be the best way to provide insight into that. Now obviously you'll be able to look on something like, say blocks.io and see that like LIB is moving forward. But if LIB stops moving forward, the reason likely is that there aren't enough finalizers up and running. And so we need to like know who is not voting when they should be. So that's the sort of thing that, like, how's the best mechanism for doing that? I'm sure there's people on the call
Ideally
that
through an API.
yeah, so
Needs to be
API or
available.
Prometheus or both or something.
Well, and I know Matthew is probably the king of getting alert, and whenever somebody misses a block, I know how I believe it kind of functions mechanically. Mostly it's based off a lib, just because you had to avoid it. Although I don't want to, you only got so much time. Matthew may have an opinion, or do you already know Matthew's opinion because y'all talk every day over coffee, but y'all break shit maybe. I want in. Call me. Anyway, he may have an interesting way of how do you know when a block producer isn't producing accurate, right? Matthew, do you have any opinion? Maybe not. I'll put you on the spot. Oh, I'm tired of scraping logs. All right, that answers my thing. Basically, you know what the schedule should be. You know when there should have been blocks. And once lib is passed, EOS USA was supposed to have blocks, this one, this one, this one, and this one. And it wasn't EOS USA. It was nations who stepped in next. Therefore, EOS USA missed a couple of blocks. Missed one block because they got forked out and were late. Missed all 12 blocks because their shit's on fire and they're just not doing it. And then, but you can only really rely on lib because anything micro fork, you can see when somebody decides to go head block and it just goes crazy because micro forks affect everybody, right? So once you go to lib, then, which is already delayed by 3 minutes, you cut that to 6 seconds. Obviously, the same mechanics works. You can just detect it much quicker. But then you're way more of the mechanics. And I don't know how that's going to be reported back.
It's not just lib, like if you're checking the logs, right, you can see when someone is not producing when he's supposed to. And instead of scraping it, what Kevin is suggesting is maybe like Prometheus, which is going to do something similar, like output through like Prometheus that information, but ideally even have like a REST API where we can get like, it tracks like for the whole round, everything, so that when you ping that API, you're getting back like, so far this round, this is what happened as of now.
Correct. That's where I was going, is how do you plan to expose that? Because like right now, all we get is a schedule and then the logs of who did what, be it at lib, be it at head block. I mean, wherever you're at, you're just really kind of being like, oh, this didn't happen like I was expecting. Therefore, it has to be this person that missed. Now, if you're doing validation on everything, yes, you'll notice the lib is lagged, but really you need to know, well, who's the reason the lib is lagged. Maybe the last vote would somehow, provide that information. Nothing on chain for votes. And doesn't really have to be. I mean, but that makes it a lot more difficult because now you're back to, you need a node to expose something. If you're writing your own API, absolutely, we can tell you exactly what all needs to be calculated for somebody to be like, who's doing their job and who's not doing their job fundamentally. I mean, I don't what was expected versus what you got, you know, I mean, what's the delta? I don't, but right now you basically have to scrape what the logs are spitting out, the node, and then realize what should have happened didn't happen. And I guess I'm curious how to getting away from the finalizer. Does it still look the exact same from a proposer? Isn't that what you called it? The actual 200 milliseconds every block that's
Like this will run not necessarily on your producer, like you can run it on like a node that is well peered.
I get that, and that's why but I go back to, does it look the exact same that EOS Nation has proposed this block at this time with this many transactions? We're still going to have that exact same mechanism to detect a missing proposer.
Yep.
The finalizer obviously knew better, but so how do we monitor it now? I mean, if you're doing both roles.
Yeah, it's a good question. That's what I'm asking. Like, how should we monitor finalizers? And as of right now, like, we have no mechanism for that. So we need to provide, I think, something.
Well, it's also different because the finalizer, I think, is kind of what Eric was saying. You know, you're counting votes versus your block proposers are a more scheduled, static round robin.
Yep.
You know what should have been there. You can you scrape and detect what's missing.
Yep.
That's the mechanics.
Yeah. So you can think about it like currently as the block producer, like you could have a script that woke your node up. It could produce its blocks. You could shut it down, you know, and as long as you brought it up in time for it to sync up and produce its block, you could do that every round, and no one would know, right? No one would know that that's going on.
We do that. It's if you got a fast enough node, you can bounce it in between your rounds. Yes.
Yeah, and people do that. You do that to like do an upgrade or whatever, or whatever you want to
roll
do.
the dice.
You're watching. You're like, okay, I'm done. All right, now I'll shut down my node. I'll do my whatever I need to do, and I'll bring it back up, and hopefully it'll sync back up and be ready by the time. Yeah, and so you're like, oh crap, it's not, you know, and you miss around. But so now though, that like that finalizer needs to be up and running all the time, because its job is for every block to vote on that block, every single block. So you can't just be down for a while. You need to be up and finalizing those blocks. And so we need a mechanism where we can say, oh, this finalizer key who's registered and is supposed to be finalizing hasn't finalized for a while. And we need to, like, you know, set off some alarm bells that these guys need to fix their finalizer.
Well, yes and no. I know part of the problem, at least we run into, I assume it would be the same, is you have to know you're in the schedule to know that if you didn't vote or produce the blocks,
like Node EOS knows all this information, right? Like
I agree. No,
like Node EOS knows all this information. So like I think Kevin is talking more about the mechanics and what you want to show, not like how can we retrieve this data. Like I'm pretty sure they know very well how to retrieve the data and expose what needs to be exposed. And this seems like like what I would think is both Prometheus and some type of either like plugin or HTTP option to expose like basically, so Node EOS would store its own like tiny database of last, say, X blocks, and then you can see for every block who finalized, which BP finalized, which BP or which finalizer finalized with what key. And as long as you expose that through API, people can write scripts to create alerts and to automate failover and everything.
I mean,
right.
I agree. I guess
Matthew asked about on-chain. Like there is on-chain a recording of the votes, if you will. There's quorum certificates. A quorum certificate is a BLS accumulation of votes. And so like with some work, you could figure out from that quorum certificate which which votes are active there. That might be one mechanism for providing, decoding that information. You can look at it. You could look at it that way. That might actually be the best way. Maybe that's the way we should look at providing it. Or it could be a real-time API call to an ODS, or spitting it out via Prometheus. It'll also be coming out via ship. So that information is being created right now, where we can export this stuff for ship. Now it's done for ship so that it's available for IBC purposes. So that's currently in work as well.
I mean, I don't know. Maybe I was misunderstanding, but the problem is fundamentally, and it's still what you're saying, it's hard to figure out ahead of time what should have been right. Therefore, I mean, to detect what's wrong and respond is the problem. So yes, if you want it at a simplistic level, some sort of an API that's counting, hey, this is the last validators that didn't validate like they were supposed to. And I mean, I guess it's every half a second, so it has to be cumulative. Otherwise, that's a pretty intense query. But like I say, that's always
the current
been the problem.
certificates go out to everybody more or less at the same time. That's why like the BPs need to be up, even like that's what Kevin is talking about. You need to be up even if it's not your turn to produce.
Well, you're finalizing.
You're not limited to the clock.
Correct.
Your finalizer needs to be up all the time. Yeah. And if it's not, like, we'd want you to fail over to a backup, so that you're finalizing, so that that we have a number of votes. Now, really, just like with, for LIB to move forward today, you need 2/3 plus one of your block producers producing blocks for that to happen. If you fall below that, then LIB stops moving. Well, it'll be similar to finalizers. If we don't have 2/3 plus one active finalizers voting on blocks, then LIB will stop moving. And so that'll be the indication that everybody will see. It's like, oh, LIB stalled. Like we went from a few seconds to like it stopped moving. What happened? Well, not enough finalizers are voting, and
Yeah, but that's only if the chain stops. That doesn't detect if a finalizer is actually offline. That only detects if enough of them are offline.
Yes.
And something needs to respond. So I mean,
yeah, so that's why I'm saying we want some sort of mechanism in place. Like, this is why I want to start this conversation. You guys start thinking about, like, what would be, what sort of mechanism would you guys like to be able to monitor that, that, hey, this finalizer is not finalizing and we need to like go shame them, or, maybe in the future slash them or something. But, for 6.0, at least, it's just going to be the same mechanism of like, well, you become a block proposer and finalizer because you have enough votes to do so. And so, we'd have the same mechanisms that you have today for
really, if we have
don't propose.
Really, if we have the data with, a different level of verbosity that we can set initially, not even targeting what the final will be, I think that will give us much more info. So maybe want to see, because you also want to detect network latency potential. Like you can see someone getting like later quorum certificates to verify previous ones, or like what is actually happening at every person's level. And that I think should happen at like potentially the node level, where you set that because it might take up some resources. So it's like a person has to enable it, and then you set your verbosity level. And from then, I think we can figure out like what different issues look like, or what we can, use to figure out those issues. Because it's not just going to be like the person is down. It could be latency, it could be other issues.
Right.
So I think having as much info and then building tools on top, like scripts, open source scripts or whatever, that can deal with this verbose output.
Right, right. Because
So
one of
you're
the things
saying
that
dump
you'll
it to
have,
the
like in every
logs.
block, is well, it doesn't have to be in every block, but if there's enough, there will be in every block a quorum certificate, and part of that quorum certificate is a list of who voted and how they voted. You can vote strong or weak. The details of that are really not important, but who was able to vote within that. But that's stored, we store it to not take up much space. So it's a bit set of simply, who voted, and then proof of that in a key, in a signature. But something like, Blocks.io or whatever, your Explorer or whatever mechanism could look at that, okay, what is the active finalizer set right now, right? You know the active finalizer set because you're watching that change on chain. So you have an active finalizer set, and you have your bit set of who voted, and they're in the same order. So you could just look through them and say, oh, okay, these are the ones that voted, and these are the ones that didn't vote. And it could report that, all right? You could imagine a UI that just had a list of them with check marks or something.
And do we have a timestamp when their vote was received?
No, well, because the quorum certificate would be in the block, so within the block time, 500 milliseconds or so of that block, who voted within that time span.
Okay.
I think then we're probably going to need an extra piece of metadata when we register the keys, because an organization may have multiple keys they register, or they may not know exactly which keys they've registered. Or for an outsider, if we wanted to say this particular finalizer hasn't been active in a while and we wanted to drive an escalation, we may not know who to tie that back to. So providing an extra piece of metadata, simply like an org name or something, may be helpful for aggregating information together in a dashboard or driving a contact point or escalation.
Isn't the validator associated to the key?
So when you register a finalizer, there is a description, and you can use that to correlate them, or like something, a block explorer can display that so that it's easy to see, a description of this finalizer. Presumably that description would be similar to whatever you use for your block producer, so your block producer name, for example, might be a good description, or something along those lines. But it's merely for humans to help them correlate the two together.
But it also, most proof of stake mechanics, if that were the mechanism, is anonymous as a key only.
Mm-hmm.
It looks for that key, and whoever has that key,
right,
is that. There is no notification, or you don't need to know who it is. What's important is the person who has that key and cares about that key be able to detect, shit, my key did not get included in that block. Great news. It wasn't all of us, so it didn't stop the lib, but enough votes, but systematically. And it sounds like it's at every single block, at least, current state. What Shaq's saying, and I guess I agree at this point, maybe, is spit it out, because it's going to need to be at the node level. It's not on chain. Spit it out maybe as like a debug message or something like that. Here's the validator's either info, where you could say that this is what it was, this is what it is. This is what it should have been, this is what it was. Or even if it's just notification of, hey, this validator's votes should have been there, but they weren't there. And here's your way of scraping the logs and seeing it, and then take it from there. Right? Having a debug level of the consensus, especially if it's not on chain, probably might not be bad to have a logging.json to say, fine, you want it, here it is. Matter of fact, here's expected, actual. Do what you want to with it. Does that make sense, Shaq? Is that kind of what you were saying, right? Just spit it out at the node level and go.
Well, more like track it, store it, yeah. Because you want to see also a bit past. and then be able to expose that through API at different amounts of like for different like detail level. I'm just saying that instead of figuring out exactly what we want to expose now, let's expose as much as we can, and then we'll figure out what tools we want to build to detect different types of problems using all the data, and then maybe the standard becomes like that limited amount of data that is needed.
Well, that's what I say. If you spit it out to the logs, which you're scraping mostly anyway, right? Then you can start, I mean, you could develop an API to show the same thing, but you'd have to call it every half a second to keep up with the head block. That just seems brutal. So that's why I'm like, it seems like the mechanism is to dump it to the logs if you want it. It can then be scraped, ingested, and processed. I mean, it may be a chunk. I don't even know what kind of data we're really looking at, but the logs seem like the easiest thing versus building a mechanism, an API, right? When we don't even really know what the API is supposed to show yet, right?
Yeah, I mean, certainly logging is simpler than API.
But if you said that it basically is two things, and Brian, I know you want me to shut up. There's two main things: the expected vote schedule that was quorum, and here's what I actually saw, and it changes every half a second. So either it needs to be a heavily tracked inside the node, or just dump it to the standard out logs and say, here it is. Even Prometheus can't keep up with half a second different data. Does that make sense? Prometheus would need it to be batched into 30 or 60-second jobs, sums, because I don't, Ross, you're a Prometheus man. I don't query anything in Prometheus every half a second or a second. It would, I think, crush it. It's much wider intervals. So you'd miss that every half a second. So really the only way to keep up with it is fine. Here it is in a fire hose, scrape it, but you can figure out this key didn't vote. If you care, here's your sign. Make sense?
Right.
Maybe.
So I think we're saying the same thing is like maybe
I
output
think.
it to log. That would be the simplest thing initially, just to consume the data, and then later figure out what data is going to be ingested from, usually like ship or diffuse, something that could keep up with like live basically connection, socket connection. And then figure out if an API needs to be built to make it easily accessible to others.
Yeah, see, I mean, Prometheus has some extra logic built into it. So, and we're already kind of having to scrape the logs and deal with it anyway. So at least let's start there. I would say the data, maybe I think of it as like a table you were saying, right? Key votes, actual votes, and then we can compute a delta in between them. Track it historically, do whatever the hell you want to with it. Anyway, I'll shut up, Brian. Sorry.
No need to apologize.
Hey, Ross.
In honor of Ross, we're going to go another hour. No, I'm just kidding.
I like this time slot, by the way, the one that you guys have just had. If I had have known it was, I would have been here.
Yeah,
It's
sorry.
earlier for me. It's 9 o'clock at night, so that's great. It's 10 o'clock now.
You know, we were going to not do the time change or whatever, but I called up the president and said, hey, let's keep doing it, bro. And so we went ahead and did
I
it.
blame you. I blame you.
Yeah, I'm just kidding. All right, well, thanks everybody for joining. I think there's, we'll probably do some debriefing after this conversation, sort of internally to figure out next steps on this, and we may pick up this conversation next week with, based on what we've taken away from this call, more pointed desired outcomes, if that makes sense, as to what we want to walk away with this from this with. Oh my gosh, brain. But so we'll see you next week, and new time for those whose time change schedule is different than the US, and we'll see you there.